Okay, welcome to day 2 of the Blacklight Summit. If you can see on your screen, we have a link that points you to the agenda for the event. This is where we have notes and sort of more detailed version of the schedule. tinyurl.com/blacklight-summit-2020. We're going to start today with a series of lightning talks and presentations, followed by an Ask Anything session and 2 breakout sessions, indexing and integrations, and customizations and sustainable development practices. Before we get started, I wanted to just remind people of the protocols for communication, just in case you weren't here yesterday. First of all, we are under the Code of Conduct for Code for Lib. We do not tolerate harassment in any form. We've created a very welcoming space here, even in the virtual space. And if you have any concerns and if someone is treating you poorly or you have something you'd like to report, you can reach out to any of the community support volunteers. They are James Griffin, Anna Headley, Hackmaster A on the Code for Lib Slack, Francis Cayua El Cromulente on the Code for Lib Slack, and me, Nikitas Tampakis. So the Code for Lib Slack is where all of our chats are directed to at the Blacklight Summit channel. And if you aren't there yet, you can join by signing up at codeforlib.org/Slack. How about we all say hi and reintroduce ourselves today to see that we're here and to get ourselves awake in case you're just waking up on the West Coast. And people who are giving their talks this hour should be promoted to panelists in order to give their talk, and they can share their screens. Without any further ado, I'd like to turn over the control of the screen to our first presenters of the day, Anna Headley and Francis Cayua, giving a talk on administering Solr. Take it away.
Can you all hear me and can you see the screen?
Yes to both.
Anna?
Hi, everyone. I think you can probably hear me too. Hi, everyone. I am Anna Headley. My pronouns are she, her, and I'm a digital infrastructure developer at the Princeton University Library.
Hi, everyone. My name is Francis Cayua. My preferred pronouns are he and him. I'm a developer operations engineer at Princeton University Library.
And today we're just going to share about how we Solr. I'm starting off with configuration management. So we have a single dedicated repository that holds our Solr configuration sets for all of our applications. You can see a little list of them over here in this picture. And for most of our applications, we just have one config set that we edit and deploy it to staging, deploy it to production as needed. However, for our catalog, where our configs are touched a little more frequently and tuned a little more finely, we have several config sets. So we have separate config sets for our staging environment and for our production environment. And that's just to allow us to do longer term testing of new changes that we're introducing on staging before we actually push those changes to production. And we also have 2 config sets for production itself. So that allows us to make a change that might require both an index and a query side change. So we can push that new config set to a collection, do a full index so that we can get that new behavior in place, and then swap over to that new collection using a Solr alias. Next slide. So this repository also handles our deployment of our config sets. We deploy using Capistrano, and it's pretty standard. The Capistrano configuration is just there to push all of the config sets up to one machine per Solr cloud instance. So we have a lot of different Solr instances. Currently, we have a Solr 8 instance. We have a Solr 7 instance because we haven't moved everything. I lost my, looking at white screen. I don't know if everyone is just seeing white screen now. We also have obviously production and staging for both of those instances, and we even have a couple of standalone Solr non-cloud instances for various other applications. So our configs are just pushed up to one machine in each cluster, and then they're loaded into Zookeeper just with little tasks that wrap the Solr API. And then the collections are refreshed to pick up the new config sets. And I'm ready for, thank you. So we also have some testing in this repository. We're testing query behavior here for a few of these configuration sets for the catalog, for our GeoBlacklight application, and also for our new ArcLight application that we're working on. Indexing logic is all tested with each individual application. So we do have to generate fixtures in this repository for our config set tests. And we can't just pull those straight out of a live Solr instance because we want to make sure that we're getting all the fields, and we don't want to miss the fields that might be just indexed but not stored. So we produce our fixtures either by running Traject or a similar analogous indexing program on an individual record just to get its JSON output, and then we can put those files directly in our fixtures directory in our config set repository. Next slide. Thanks. So that's pretty much all I have to introduce for this config set management, but I just wanted to mention pretty recently taken over leadership of this repository, and have a couple of thoughts of things that we might want to do here. One thing I have been thinking is that we might like to move the config sets themselves back out into the individual applications. This would allow us to take better advantage of application logic in the query side tests themselves. And it would also make it easier to generate the fixtures, make it easier to keep the development experience more consistently in sync with what's in production. Currently, we have rake tasks that will pull config sets out of this central repository and into the various individual application repositories. So if we do this, then I think this PUL Solr repository will become more strictly a deployment tool, and it would be sort of reconfigured to pull configurations from each of the individual repositories and push them to the various Solr destinations where we would need them. I'd really be interested in hearing how other people are managing config sets. So please do reach out to me. My contact info will be at the end of this talk. And next, Francis will go over our provisioning strategies for Solr.
Hi, so Anna described the software, and I'll talk a little bit about our hardware management. We've selected to use Packer from HashiCorp. Packer is an open source tool for creating identical images for multiple platforms. For the purposes of this talk, all of our Packer images are deployed on a vSphere environment. It is used for our staging and production. the way Packer works and the image that we build allows us to have a administrative user. This user's authorized keys are pulled from all of our developers' keys on GitHub. And the virtual machine image has pre-configured firewall configurations that will block automatically as it comes in, except the aforementioned keys from GitHub. The image can be used on AWS, possibly Google Cloud in the future, but as I mentioned earlier, it is currently only used in our vSphere environment. This repo is currently private. I cannot remember why. One of my tasks is to open this up if other people want to use the strategies that we use. So for the purposes of this talk, we have identical virtual machine images for our staging and production. Our Solr Cloud implementation creates 3 identical Zookeeper machines and 3 identical Solr Cloud machines. After the images come up, I failed to mention that the Packer image bootstraps with Ansible. Ansible is our tool of choice. Our initial Ansible role was heavily influenced by Jeff Geerling's Solr Cloud Ansible role, so you can go and look at that. One of the changes that we did make is we decided to use Jeff Geerling's role mostly because it mirrors the Lucine's taking Solr to production document. The changes that we made to his role were mostly around Zookeeper. We removed all the operating systems that we don't use. We added the molecule tests. Molecule is Ansible's testing framework. And the significant one was mostly around a project that Anna and I were working on in the last couple of months. And our initial decision didn't have a Z node, and the huge improvement we feel we made is allowing us to have multiple Solrs in one Zookeeper cluster by making sure that our Ansible role will spin up the virtual machines, which will be able to create themselves in a Zookeeper ensemble. If you want to reach any of us for further comments, or if you have any questions about what we do, our contact information is listed on this slide. You can find us in the Code for Lib or Samvera Slack, email, and or Twitter. And that's it. Do I hand it back to you, Nikitas?
Yeah, sure. Thank you very much, Anna and Francis. This is the talk that I would have loved to have heard before implementing a Solr Cloud instance, and I hope it makes that it's useful for other people going forward if they're thinking about switching to Solr Cloud or thinking of ways of making it more sustainable. So up next, we have Emily Morton-Owens, who will give a talk about the Platform for Open Discovery initiative.
Okay, is my screen sharing active here?
Yes, and we hear you.
Okay, great. I'm gonna have to switch windows partway through, so I might have to pause and fiddle with it again. Great. Well, thank you for the opportunity to present in this venue. My name is Emily Morton-Owens, and I'm the Acting Associate University Librarian for Library Technology Services at the University of Pennsylvania Libraries. So now that I've spent my whole 10 minutes introducing myself, what I'm really here to talk about is the Platform for Open Discovery, which is an emerging project among the Ivies Plus institutions. Oops. So I don't want to read this whole slide to you, but the main idea of this project is about data sharing and data reuse. We had a sense that so much of what our libraries want to do together grows out of our data, and bib data in particular, and that if we considered sharing our data as a first order goal, it would enable a lot of new things. Moreover, by trying to make the data formatting and sharing requirements really easy to satisfy, we wanted to make it possible for institutions to join in, even if they didn't all see themselves as immediate consumers of the data. And we also wanted to allow reuse of the data in ways that we hadn't foreseen yet. Among these use cases, I think discovery is a major purpose for the data and one that several of the institutions are particularly interested in. Could sharing this data lead to a better BARA-direct experience, for example? Could it allow us to ingest the data into our local index? Could it allow us to have a more immediate and robust response to something like service changes due to COVID-19? This list thinks ahead to some more exploratory and less transactional uses of the data. And who knows what we would do with it once we stop having to have conversations that end on a note of, well, we could do that if we had access to all the data. These are the institutions that have been most active in the project and the project board so far. But recently, some others have started participating more actively in our discussions. And this is the list of the data that we worked with initially. The 6 institutions on the previous slide, plus Harvard, Columbia, Princeton, and the Hadi Trust. We're currently working with over 75 million records, but we're interested in adding more. So I'm going to very briefly just introduce 2 demos that we created. And this is where I'm going to have to switch windows. That did not work. Hold on, I'm going to stop sharing and start again. Okay. Are we seeing my other Firefox window now, I hope?
Yes.
Great, okay. So both of the demos I'm going to show you were set up by the Penn developer, Michael Gibney, who did Penn's intro yesterday, so I think you know him. This first one we're thinking of as Pod Cloud. So this is a version we can envision living in the future, not on a Penn server, but in the cloud, and serving as a utility for exploring the data. And I think when you use this, the first thing you'll want to do is choose an institution to prioritize. Because what this system will do is that it will do the deduping at query time. So if you don't choose an institution to prioritize, it's going to show you all of the results kind of like loose. And I think it's a little easier to understand if you choose. So I'm choosing Cornell kind of arbitrarily here. And I'm going to just do a keyword search that I did yesterday and I spelled wrong the first time. So this is just the regular relevance ranking on a keyword search. And you'll see even with Cornell prioritized, that the first result in the relevance ranking, Cornell does not even hold. And so it's a mixture of records that we've gotten from these different institutions. You'll see here that the first few facets are specifically related to this particular data set, but as you scroll down, you start to see blacklight facets that look a lot more familiar. If we click on a title to go into a bib record here, this is kind of where we see the priority working. So we have all of these records from different institutions that you can click through to, but what this is doing is it hasn't discarded the additional bib records. It's just choosing to show you the Cornell one because you picked that at the outset. But we can look at any of the others. In this case, they're not terribly different from each other. Let's see, Princeton has a local note, so they're all here. Yeah, and so this is the first demo. And then in my other tab here, I have the other version. This is where we're sort of picturing what it would be like to have all of this data in a local catalog with Penn's own collection as the default, but then you can zoom out to see the rest. I cheated a little bit here. I logged in advance, so you didn't have to watch me do 2-factor. And I've gone to our catalog, so I'm not doing like summon or databases or website or anything. So I'm just going to do another keyword search here. So for this, initially we have 46 pen results. This is exactly like our production catalog, right down to our COVID-19 message. But what's different in this as a demo is that we have this include partner libraries choice, which has many more results. And again, some of the most relevant ones are actually not held by Penn. So we think this would be a really exciting way to bring this material sort of forward and just make it a lot more readily available to our users. We did implement sort of a prototype of borrow direct requesting here. This goes to a sandbox, so I can push it without causing havoc. This is kind of skeletal here. We could include more bib data and info. If I click submit request, it does submit a real request to the sandbox. I'll get an email. And then if I were to click here, I can see all of the fake requests that I've placed recently. Okay, let me go back to the slides. Okay. Sorry. Okay. There we go, sorry. All right. So up to this point, our work has been somewhat focused on discovery because I think that's a driving interest for several of the partners. And one of the reasons I was interested in sharing this work with the Blacklight community was because Blacklight really was essential for us to be able to build that demo. And that as we move forward, it will be essential for us to eventually offer a platform that should be superior in usability and performance to what we've had in the past, and in our ability to reuse the data locally, like in that Penn version of the demo. So Blacklight has really been one of the accelerators of this work. That said, our next steps will be more under the hood. We're working on a process to create regular data refreshes and infrastructure for the data lakes. We also want to test out mechanisms for clustering the records. The demo is just based on OCLC numbers, but not all the institutions have the same coverage of OCLC numbers and records. So we want to determine which additional matching factors would have the best results. And finally, here are a bunch of links for you to try out those demos if you haven't already, or join these mailing lists. I know quite a few of the institutions that were represented in yesterday's demos are members of the Ivies Plus, so I'm hoping that developers from those institutions will check this out if they haven't already. The communications channels are intended for the Ivies Plus institutions that might participate in this project, but we are really interested in sharing ideas and approaches broadly. For example, there may be consortia elsewhere that want to try doing something similar. This is a project where we've made a lot of progress, I think, by kind of trying to frame our objectives in terms of, what can we do for real now? And then pushing the envelope on what we can do for real going forward. And I think that makes it an easy project to join in. The project governance is getting a little more formal because some of our institutions are now looking towards having production dependencies on pod. But we're still really interested in having open discussions and brainstorming. So thank you for your time. I hope everyone has a safe and relaxing weekend.
Thank you very much, Emily. Our next presenter will be David Kinzer to talk about Traject wrapper apps.
Hello, good morning, everyone. Happy to be here, and thank you for allowing me to talk. I'm going to share my screen now. Okay. And can you all see my screen?
Yes.
Okay, perfect. All right, so this talk is going to be about some Traject wrapper applications. I'll talk about what Traject is in a little bit, and how we use these at Temple University for our ETL of data. All right. So what is Traject? Traject is an application written by, I believe, Jonathan Rockin, and apologies, Jonathan, if I'm mispronouncing your name. That is basically a tool that you use to grab things from an endpoint like Solr, CSV, or an OAI, and extract that stuff and process it in some way, and then turn it into a Solr document and push it up, Solr JSON document, push it up to your Solr instance. And usually, this works pretty well. But every once in a while, as with us, we start to have to make some customizations, and most of those customizations were essentially kept in the application, in the basic search application. And at some point, when we started to move to using more robust ways of processing this aspect of our application, we decided that it would make sense to take that out of take the code that we're using for Traject and our customizations and all this stuff out of the application into its own sort of script or executable that we could use, sort of like kind of like Traject, but more flavor toward our things. So Traject can be used as is as an executable to do this, but it can also be used as a library. It turns out. And here's some of these. These aren't all of them. These are the main ones that we use for our search. And I'll post this so that people can see the links later. But we have one for our catalog ETL. We have one for databases. We have one for our web search, that sort of thing. And then just quickly, I'm not going to go too big into this, but I should say I chose GLI, which is a gem, to wrap these, essentially to create this command, which in the demo I'll show what the command looks like, the command line application. And I basically chose it because I'm familiar with it with other projects, and I think there are other off-the-shelf stuff that you could probably use that do a similar thing. This one in particular has a sort of a Git flavor. So if you're used to the Git command line interface and you want an application that has that, then this is a nice choice. That replicates that. All right, so why did we choose to do this? So these are the sort of a list of the pros, and then I'll give a list of cons. So we wanted to run our ETL without having to download the Blacklight app, the entire Blacklight app dependencies. So that was one thing that kind of drove us in this direction. So we were, when we were running, essentially manually running the Solr instance, we would happily run the rake task. But when we started moving away from that and doing things more programmatically on inside a DAG or something like that, then we wanted to not have to always download all the Blacklight dependencies just to do the Solr, the Solr ingest and indexing part. Another reason we wanted to decouple making changes to our ETL process to making changes to our Blacklight application. So like if we had a PR, for instance, for an ETL change, something about the index that didn't require a Blacklight application, and we could just deploy that. We didn't want to have to wait for regular Blacklight or application deployment to, or get anything inside the Blacklight application, or which is our search application, to mess or hinder us from making those changes to the ETL process. Another reason to do this is you want to make your own sort of custom changes to the way the Traject would normally behave. So Traject has a lot of configurations, a ton of ways to configure it, but every once in a while you run into an issue which is very custom. It's very, this is an example. We wanted a way to delete things in a very specific way. I created a PR for to have it accepted into Traject, but Jonathan didn't think that it was, that it would apply to most people. So like in those cases, it's kind of nice to be able to just apply it to your own application, and that's another reason why we went this way. And the other thing is that it's nice now, we have, I showed you 3 of these types of applications, but it's nice to have this template for creating these types of ETL command line apps for other reasons. I think we have it for other projects, Funkcake DAGs, and other OAI type, DPLA type things where we use similar applications, command lines in the process, and so we kind of developed this way of doing things, and this knowledge base that we can use over and over in different places. All right, so how do you actually use this? Actually, it turns out to be pretty simple. As a library, you could just grab a Traject indexer, and you can load your original config file. This is what we used to use before as our configuration. You could just load that using a load config file, or it could take a block here as well. And then you could just process the indexer. You could just process. So this would be basically what would happen if on the Traject end, but you're doing it in your code. So it's actually super simple to wrap Traject into your own command line application. And this is not the only thing you can do, but this is the basic. Oh, we got to the demo section. So let's do a quick demo. Let's see. So I have my local application here. Actually, this is, let's say, for instance, that I did a quick search that there was a problem with this document on production, and I wanted to test it locally, but I don't have it on my local results yet. So what I would do is that I come here and I would grab my, I would grab this URL, and then I would go, now this is in my local, I'm inside a container right now, and I would just run cob index. Now I'll just show you a cob index. It's a little laggy in here inside the container, but cob index can do, we can use it for some deletes, for a harvesting process, for an ingest process. And it's growing over time, it grows with different functionality. But in this case, we're going to use it to ingest that one record. So I would just say cob index ingest, and I would pass a commit command here, because by default we don't commit, because we use this inside of our ETL sort of process, where we don't want to commit every single time. We want to commit at the very end. And it's not at the very end of just running Traject or cob index once, but running it over like many different files. So we want to commit at the very end of that. So and then I would just pass it the URL, and it would do its thing, and it would just process it. You're probably very familiar with that. It's basically Traject, right? It's basically the output that Traject has. And then, of course, I would be able to then go to my local host here, and I should be able to see that inside my So now I should be able to like run my test and my whatnot. Oh, there we go. So now I have it on my local instance, and I can test it. I can figure out what's wrong, do a PR. That's the demo. That was a quick demo. All of these apps are open source, so feel free to copy them, update them, be inspired by them. My name is David Kinzer again. I work for Temple University. My Twitter handle is DTKinzer, and my GitHub and Code for Lips Slack are just dkinzer. And thank you very much.
Thank you for your awesome talk, David. Our next 6.2-minute talk is from Chris Beer, talking about view components in Blacklight. And this one's pre-recorded. I'm going to share my screen. Make sure I check the share computer sound button. And let's go.
Hi everyone, my name is Chris Beer, and I'm a software developer at Stanford Libraries and have been a Blacklight contributor for many years. Today I'm going to present on some recent refactoring that's gone on in Blacklight to start to support view components. Justin talked about view components earlier this summit, so I'll quickly go through the basics. In a lot of ways, view components are not very different from partials and helpers at all. For Blacklight, I see several benefits to this approach. First, we get to encapsulate view-specific logic where it's easy to test and reason about. And second, we get to define a very explicit interface and data flow between Blacklight and your application that makes it easier to work with application-specific customizations. So to get a sense of view components, let's walk through a quick example. Here's a simple view partial, some HTML with a title, and let's say we want to extract that title out so it's reusable. We pull out a partial like we do here and pass in some content. And that's all well and good until things start to get complicated, where we might be passing in some content, we might be calling helper methods, we might be using instance variables, and it becomes very difficult to reason about where the content's coming from and what's going to be displayed to the end user. And so if we turn this into view components, we get to be very explicit about the information needed and how it's displayed. So at the top we have the view, which renders our component with some information that needs to be passed in. Next we have the component with the information about what needs to be passed in for display and any view-specific logic. And then we have the ERB template that has the markup that's actually displayed to the end user. In Blacklight, the first thing we've converted to view components are facets. So now we have three different components: the facet field component, the facet list component, and the facet item component. And if we take a look at the facet field component, which defines how Blacklight facets display in the sidebar, we can see it's fairly simple. The contract is just a label, a body, and the facet field itself. And here's the markup to support that. And whenever you render this component, you get something that behaves just like any other facet field. By refactoring facets into some fairly basic components, we're able to really clean up our facet helper behaviors. And once we're at Blacklight 8 and able to remove deprecations and backwards compatibility, this very long file should be reduced to just a handful of methods. So that's great for Blacklight and Blacklight's maintainers, but what does it mean for an application maintainer? Here I am with our Blacklight internal test app with some data seeded into it. First, here in the CalAuth controller, I have found my facet field configurations. And here I have a couple new options available to me. I'm able to tell Blacklight to use a custom component when it's rendering the facet field by using the component configuration, and I'll give it a name. I'll just call it my facet field component. And here's the Ruby code to support that component. As you can see, there's nothing going on here except delegating to the upstream facet field list component. In Blacklight then, the upstream component gets two parameters. One's the facet field and one's a layout. Facet field happens to be the facet field presenter that has all the information about the configuration and the data from Solr. Over in our application then, we can start by going to the template and starting to fill it in with some content. Let's start with just some dummy content, and let's make sure it shows up. There we go. We're using our custom component to render that facet field. And so let's do something a little more interesting. We'll go ahead and copy the content from Blacklight's ERB template. First off, we can see we have a label here. We'll put some dummy content in it and see it show up. And we have a body, which is the content of the facet itself. We might decide to append a H2 or something to it, and we see that show up. We can also add things outside of the facet layout. Again, maybe another H2 and some HRs just to set this particular facet off from everything else. There we go. But what if we want to customize the facet items themselves? Well, back in the Cala controller, we can also ask Blacklight to use a particular item component instead. Again, I will just call it my icon facet item component, which I've preceded here. Similarly, inheriting from Blacklight's upstream facet item component that we know receives a facet item and some other data. One thing we might do here is change the label of the facet here to use the original label, but prepend. Here I'm just going to do a little span, but you could imagine a format icon or something like that. And we'll see that show up here in region. So there's two brief examples of how to use custom view components to override Blacklight's default behavior. With this, I'm able to make very targeted and also explicit customizations with a clear contract between Blacklight and my application, and have greater confidence that they'll keep working and also avoid unintended side effects. This will start to be available in Blacklight 7.8, and you'll likely start to see some deprecation warnings soon that start to nudge you in this direction.
Sorry about that. I'm not sure if anything I said came through at all because I tried to mute my mic during the pre-recorded session. So thank you so much for that wonderful talk, Chris. It's a very exciting development that I think will just sort of shows that this project continues to sort of explore and push the boundaries, keeping up to date with what the community is doing. Our last presentation is with Charlie Morris, who will talk about dynamic sitemaps.
Okay, hopefully you can hear me now.
Yes.
If you can't, and now you can see me, maybe? I don't know. If you can see me, look, there's a ceiling fan. Obligatory shot of ceiling fan. Okay, let's get to the presentation. Okay, hopefully you can see that too.
Yep.
Cool, cool. All right. So dynamic sitemaps. My name is Charlie Morris. I'm the lead web developer for Penn State University Libraries, Strategic Technologies, Discovery Access, and Web Services. So yeah, I'm the lead web developer of that bottom group there. We're sort of doing a merger right now. Side note. So some context at PSU Libraries. The catalog is in beta until fall, as you learned yesterday from our exciting intro. Its project name is Black Cat, though it will never reach the light of day to users. We will never call it the Black Cat in front of users. The vendor provided search interface remains the primary catalog right now. That's a Circe Dynex product that's about 20 years old and is session based. It's a little rough. We have over 7.5 million records. We're on Solr 7.4. We run in cloud mode, Blacklight 7.5, I think, and Traject, which has been fantastic in JRuby. We have over 100,000 students across the Commonwealth and around the world. So initially, when we started the project, when we released, I think it was in spring of 2019, we did not let any robots in out of an abundance of caution. And as things went on and things were clearly stable, no performance issues, we started letting the bots in. So the first thing we did is we got rid of you know, I'm going to put this in presenter mode so maybe you can see this better. It's going to be a bad idea, maybe. I don't know if that's working. Shoot. Can you see that? Dang. All right, I'm just going to go with this way because I'm not sure. So yeah. So November 5th, 2019, here's what a screenshot looked like. I was happy to use Zotero to do some screenshotting along the way in this experiment. And November 5th, prior to having a sitemap in, but removing the denial for robots, 6 results. So not stellar, but completely expected. I'm assuming these links here must have been hard links from like professor courses and who knows where. So question is, how do people find you? How do people find your site, your catalog items, stuff in your repository? And this is this slide is taken from a 2005 SEO artists slide deck, right? It's Google. They're coming from Google. This is not a revelation. This is old news. So search engines like sitemaps, and they're especially critical for a site made up completely of dynamic links, because otherwise they're not going to find anything in there. So super critical, in my opinion. I also think of it as some kind of low-hanging fruit, kind of old news, low-hanging fruit to get the bots in by having a sitemap. And I think one of the main reasons I see, and this is sort of, again, kind of beating a dead horse with why Google is important, but you know, say a patron's out there looking for a book, and a lot of patrons are just going to Google, and we can blame the patron and we can blame Google, but that's not really going to do us any good. So let's compete with Amazon and maybe try to save them some money by saying, hey, wait a minute, did you know we have this book in our catalog? Come take a look. So getting into the challenge of sitemaps on a large repository and when I say large, I mean greater than 50,000. Google and perhaps other sitemap or spiders indexers will put a hard limit of a sitemap of 50,000. So once you get over 50,000, you need to have multiple sitemap files, sitemap XML files. And so for 7.5 million, you can do the math. That's a lot of files. And again, it's completely dynamic. There are no static links whatsoever. So the prior work, yeah, I was going to say, like, this whole presentation is so not trendy because everybody's into static sites, static site generators nowadays, and I'm talking about dynamic. Again, this is like a whole throwback. So Jason Ronaldo made a great Blacklight sitemap generator gem that's fairly old at this point, but still works. And I did try it out, and it works. There is a generic gem in the Ruby community called Sitemap Generator, which does largely the same thing, I think. Both of these just create, not just, but they create sitemap files, and they do it all for you, and they're actual static files on your server. So when we were letting the bots in, I think it was just dumb luck and timing that we also saw this development from Jack Reed of Stanford University Libraries and others, including Michael Gibney, and I'm going to forget the rest of the folks' names, but it happened, I believe, at the Blacklight Linked Data Summit. Anyway, Jack can correct me if I'm wrong on that. So the way this works, it's a live query of Solr for all of your sitemap data. So an actual sitemap file is just a query on the Solr database, Solr whatever. And it's a sort of a familiar pattern. You have a Rails controller to dictate what is displayed and how it's routed. And you have a view template that's an XML template as a view. So it sort of fits a pattern. If you want to see our work that brought this into our repo, you can look at this PR. I'll try to share these slides out so people can get to it. Here's the query recipe. Again, I didn't make this query. I'm thankful for Michael and others to bring this up and figure it out. But it's all based on a hex encoded hash for every single record. So base 16 encoded. You have to use Lucene as your query parser. And there's a query parameter for the signature, which is this base 16 hex encoded hash that says this, we call it the signature, starts with. And more on that in a minute. And it returns an ID and a timestamp, which are used in the template. And let's see. This was one gotcha that I noticed you have to turn off, or maybe it's not a huge gotcha, but like facets are expensive. And by default, our catalog is calculating facets. So I had to tell it not to calculate facets on these Solr queries. And also specifying a very large number of rows to prevent paging from happening, because paging is also expensive. Here is the magic for how we chose to implement creating this hex encoded hash. And it is part of Solr. It's a function available to you. Basically, it takes in the ID as the argument, and it spits out hashed ID SI. So a hashed ID SI is one of those dynamic fields in Solr. It is indexed but not stored, and it's a string. So you just have to be able to query it. I've got links to the ref guide here if you want to learn more about this, this update processor. You add it to your update processor chain. So just every time you get something indexed, it'll calculate this on the fly as you're indexing and updating. So this is the part I said I was going to get to in a minute. These are the dynamic leaves, this concept of dynamic leaves, and you can decide how many dynamic leaves you want. So the example I have here is a simple, I'm choosing to have only 16 leaves. That means I'm saying the signature starts with any character from 0 to F, which is 16 characters. And so if you have a very large sitemap of 7.5 million, that's clearly not going to work because you're going to have huge, each one of those like dynamic queries is going to produce a giant number of results. So having a bigger number for bigger sites makes more sense. So you can see, this might help a little bit even more. So we have 4,096 leaves. That's what we chose. And actually, I should say in the work that Jack and them did, they have like a formula, a logarithmic formula that kind of like determines all this for you based on the size of your max documents. And I'm not going to get into that, but you can go look at it yourself if you want. So you can see here on the left, there's sort of like a sitemap index, and it has links to sitemaps, and they cover every combination of the first 3 digits that are possible in a hex value. And then here's an example of what it looks like. So sitemap /000-001 show me every single record with a hash ID that starts with 001, and it populates that. So getting into robots, you want to put a crawl delay of 10 and make sure you tell bots about your sitemap XML. You may have to tweak your robots even more. I think I updated the robots.txt file like 20 times while I was implementing this. At first I didn't have crawl delay 10, but I learned that was important. You need that. Early returns with Google, yeah, slow growth. Super slow growth. You'll notice that it says 7.76 million excluded. Valid 32,000, which is a lot, but nowhere near the coverage we need. And so that's the top left thing. The bottom right one is sort of the Google output of like how many people are finding your results when they do Google searches. And you can see it's been, you know, slow growth again, just going up a little bit. There's weird spikes I can't really explain. But I thought this was one nice success story, and it shows why it's worth it. So how do people find you? Google puts out this like monthly report of how people are searching and finding you. Hopefully I'm not going too long here. So I was happy to see that if people who are searching for this particular author title management entry were the #1 result for, and we're seeing a lot of hits on that. So to me, that's a win. Yeah, so unamused face. 62 years is, at this rate, is how quickly we'll have an index in Google that's complete. Some lighter analysis. This is from Matomo. You know, since late November and turning all this stuff on, we've had almost 5,000 visits from Google, and search engines, I should say. So, you know, that's not nothing. It's 4.4% of traffic, so it's not huge, but it's cool. Some lessons learned. Yeah, Google is mysterious. I don't understand why it won't get more stuff. Then you do like a search for site catalog libraries psu.edu, and it shows only 2,890 results. That's from today, even though the Search Console shows over 30,000 records. So yeah, I guess that's why people make a career out of SEO. Bing was problematic. Bing was hitting our site really hard once, and so much so that I had to log into Bing Webmaster Tools to gain finer control and tell it when to come in, when not to come in. The crawl delay of 10 was important to tell Bing to relax. I think there's other crawlers that respect the crawl delay of 10 in that instruction. Google does not, but Google apparently is smart enough to not need to. Yeah, and so I changed those two things kind of in concert, and I'm not sure which one solved the problem with Bing, but it's a solved problem. Here's a screenshot of Bing Webmaster Tools, which are, it's a weird interface, but you can tell it when to crawl, basically. Let's see, future work. Keep watching the Search Console, keep looking at analytics, and talk with other folks about what they're doing. And if you want to see the incomplete gem, you can go there. If you want to email me, you can do that. And those are my Twitter and GitHub handles. That's it. Sorry if I went long. I'll stop presenting. I can figure this out.
Thanks for that wonderful presentation, Charlie. We're gonna take 5 and then go into the Ask Anything session.